So next up we have a double act. I'd like to introduce Daniel Gapes and Trevor Stuthridge from Cetogenix. Both Trevor and Daniel were co-creators of the Bioresource Processing Alliance, with Trevor serving as its establishment GM and a member of the BPA board, and Daniel contributing extensively, including to the Science Leadership Group. Daniel and Trevor are co-founders of Cetogenix, a climate tech startup company focused on generating high-value economic and environmental benefits through its proprietary organic waste to natural gas, renewable chemicals and biomaterials conversion technologies. Daniel and Trevor.
I think I'm Laurel and he's Hardy, I think, but we'll see. Most of the people in the audience wouldn't know what that meant, I imagine. Kia ora tātou, so yeah, I'm Trevor Stuthridge, CEO and co-founder for Cetogenix. And we're going to take you through a particular New Zealand project which is very, very integrated with the BPA and our colleagues in the CRIs. We are doing other projects elsewhere and Daniel will touch on those, but this is one that's really dear to our hearts because it's in New Zealand. Ironically, one of the rules of setting up Cetogenix is we would not create an industry in New Zealand, and now we are trying to. So that's what we're doing. So Genesis, as Nikki pointed out, the genesis of this, the four co-founders, we all worked at Scion in various roles back in the day, for far too long possibly, and we created the IP for this technology, and at the time we developed that technology through to a pilot plant, so that's a picture of the pilot plant. And the focus at the time was on how to turn sewage into a biotechnology feedstock and how to eliminate landfilling, because in 2013 that was the big story. It wasn't about climate change, it was about landfilling avoidance, basically. And then things happened and we all went our various ways, and then in 2022 we got back together and we realised, as I'll show in a moment, that the market had pivoted into a space that we could take our technology forward in. We capital raised in 2022, we've built our team to 12, and we'll take you through this journey. So what's the opportunity we're tackling? So there's 100 billion tonnes a year of organic waste generated all around the world, from sewage, consumer food waste, industrial processing. Agriculture is the biggest one by far. And of that 100 billion tonnes, only 2% of it is used or even treated. So the majority of it doesn't go anywhere other than probably out down a drain somewhere. And one of the key reasons for that is it's the content of the material. It's nasty stuff. It's usually high in water, typically 85 to 90% water. So any technology that's going to get value out of it either requires the waste to be dried, which uses up enormous amounts of energy, or we have to process it wet. Our technology processes it wet. These wastes are waste, so they're typically complex. They're made up of all sorts of things at any time, usually mixed up. So if we want to use this waste material, we need to simplify it. We need to turn it into a product that has a market. Our technology turns it into simple molecules such as methane, ammonia, carbon dioxide and phosphate. It's almost certainly contaminated, so these waste streams often will contain microplastics, as you would have heard of, pathogens, diseases, other pollutants. If you're going to process it and extract value from it, what you cannot do, ideally, is create another waste stream with contaminants in it that has to go somewhere else. So we've adopted a sort of no waste left behind approach. As it happens, our technology destroys microplastics and other things like that. Oops, I will go back. And then the last point, and this is where our pivot happens. So when we were working on the technology back in the day, we were looking at a $50 million plant. It would be a huge plant. It would be built somewhere in Rotorua. It would take up some hectares of space. You build one every 10 years because that's how long a council would take to make a decision on it. And you'd have to find that money. What we recognise actually is our technology, which was pilot at the time, could be commercial at that scale. That containerised modular systems will be the secret sauce to integrating waste-to-X type technologies into the market. What we also realised is because of these various challenges, there were industries like anaerobic digestion to biogas, where if we overcame some of those problems, they could become more economic and more sustainable. And that's what we did with our technology. We created a technology called Cetoboost. It's modular, containerised. It uses just pressure, temperature and air to break the material down into simple molecules. Some of those molecules can be passed on to people like EcoGas to make more gas. We make 40% more biogas than a standard anaerobic digester. All the nitrogen goes to ammonia. We now recover the ammonia and replace fertilisers with that ammonia concentrate. All the phosphorus gets recovered. We use that. We're energy positive. We generate 2.5 times the thermal energy out of the process for every 1 times the electricity we put in, because we're using the calorific value of the waste itself as a product. And we can clean up the water and return it. Target markets are threefold. BPA more on the agricultural side and industrial, but certainly the municipal market is enormous. The agricultural market is even bigger. Industrial market is really, really interesting because it's about working on containerizing a factory to be zero carbon, zero waste. They have different models, but really basically the three benefits of our technology suit those markets. Solids reduction, so no solid waste to go to landfill or anywhere else. Process efficiency, so improving the recovery of value-add products out of those waste streams. And low carbon circularity, essentially using organic waste stream as the feedstock of the future to defossilize fossil carbon type products. And what is the impact for our technology? So one of our modules, which does 25,000 tonnes a year, could process all the sewage needs of 110,000 people. So that's all the poop and tauranga can be processed from one module. One of our modules would generate enough natural gas in New Zealand to provide heating and cooking needs for 3,300 households, one module. When we put our process into the Ceto Hub, which Daniel will take you through, we could replace 100% of the fertiliser needs of that farm by extracting ammonia and phosphorus from the waste materials that we bring on site. At our total addressable market, which is 34,000 sites, we could reduce greenhouse gas emissions around the world by about 1 gigatonne. And as a company, we're quite keen on the revenue opportunities in terms of turnover.
So that technically what we're focusing on is containerising or modularising the technology that we developed, as Trevor said, its genesis back in Scion 10 or 15 years ago now. You heard earlier a little bit of talk about the TRLs, and what we're trying to do as a small startup company is take a technology through TRLs from 5, 6, 7, 8 through to commercialisation. And busy right now with our what we would have called our second generation plant, the one you see in the middle there, TRL6. So working on our own site, we're co-located on the Scion campus at Rotorua, and busy trying to develop that through to the next generation TRL7, where we're going to take this out to the field, to sites, to companies, to the relevant industries that we're targeting. One of the things that we focus on is that prototype development work, and this is one of the benefits of working in the BPA is the small scale laboratory based work. So we don't have to do that. Don't have to buy all the gear for the lab stuff. Scion Ag Research have got all that gear ready to rumble, and we focus on the bigger pipes. What's the market like? So we're globally focused at Cetogenix, and the market is big. What market are we talking about? Anaerobic digestion market. There's 9,000 anaerobic digesters working on agricultural wastes in Germany alone. And that's where we see we can add value. We sit amongst a plethora of other startup companies. Cetogenix is down on the right of this slide, just really to give a bit of a feel for there's competition in this area. There's a lot of people wanting to do a lot of things in a lot of different ways. We feel like we've got a good niche for ourselves, and amongst those technologies, and what we need to do is drive ourselves into that commercial space, and that's the singular focus that you've got to have as a company. As I've said, there's a global focus to what we're doing, working with a lot of companies and partners, some of which you see here, familiar in the local sphere. Water care, wastewater treatment sludges is something that we can deal with. Here in New Zealand and the UK, we're working with some of the largest water companies in the UK, got some funded programs there through their Office of Water, or Ofwat, so they see a really massive opportunity to deal with the sludge to land challenges that exist over there. In the area of agricultural AD, Trinity Lands, big operator in the central North Island area here in New Zealand. Nature Energy, one of the larger anaerobic digestion companies based out of Denmark. sold to Shell for $2 billion a few years ago, and developing an interesting relationship with the likes of PepsiCo. What's the New Zealand market? We're talking about anaerobic digestion here. What's the market like? As Andrew attests, there's a massive opportunity. So that's all that this slide says. There's a big opportunity in New Zealand for anaerobic digestion to add energy value to the New Zealand sector by way of renewable natural gas. And it's a famous table taken out of the Becker report that says just that. And where does a lot of that come from? It comes from the agricultural sector. So that's the confluence of where the BPA's interests are, of course. So we're an anaerobic digester company, or an anaerobic digestion company. Well, no, we're not. So often people say, oh, yeah, you guys are anaerobic digester. No, what we do is add value to anaerobic digestion. So our technology, we take our technology and insert it appropriately into the infrastructure of anaerobic digestion to add value to that particular site. And so we've been working on developing a concept which we call the Ceto Hub. So a hub concept for as we saw, agricultural opportunity in New Zealand for AD is high. So dairy is massive in amongst that. So locating an anaerobic digestion on dairy farm is a really good idea, but it does come with a lot of challenges to make that work effectively and economically. And so a hub concept could be thought of co-location on a farm and bringing in residues from around the area. They might be forestry residues, they might come from a dairy factory or meat processing or horticultural residues. What does that do? It's basically bringing in energy to add more hoof to the anaerobic digester. And so what we do is insert CetoBoost into that hub and deal primarily with the digestate that comes out of anaerobic digestion. And as Andrew made Jaffa juice, we make Ceto juice. And so what we make Ceto juice to do is feed back into the anaerobic digestion to make more gas. So we're taking the potential that still remains and making more gas. And in doing so, our technology busts up the sludgy material and gives access to the nutrients. And so we can manage the nutrients that you're bringing in. If you're bringing in nutrients onto a farm, that does bring challenges associated with it. So if you can capture nitrogen and phosphorus into a concentrated form and deal with that, that's what we think makes a hub concept work well. So make more gas, deal with the nutrients, and smash the digestate. Just a few final slides from me on what the hub concept does. We talked about seasonality, everything's seasonal in this world as far as we're concerned, and so the hub concept deals with that seasonality because you want to have constancy of production and capability. So bringing materials in that have that balanced seasonality, that's what you want to be able to do. One thing that we're really focused on at Cetogenix is what CetoBoost technology can do in the management of potential costs around digestate. So we're basically inserting CetoBoost into anaerobic digestion removes the sensitivity to costs for converting or dealing with digestates. And we want to be a contribution to carbon positive farm systems. So making more gas, substituting for petrochemically derived gas, fertiliser offsets, and you have to do this as a business. It's got to make money, it's got to be profitable, and we think there's a real opportunity there. The BPA is fantastic. I've been part of it since its genesis, and it's great to be on the other side from the giving to the taking side, and still think it's New Zealand's best money in applied science in New Zealand. So fantastic working with the BPA, with Ag Research and Scion on this project over the last couple of years. And Trevor might have a few more comments about that as we finish off.
Yeah, so we want to acknowledge the BPA and AgResearch and Scion. They've been critical. We've been working with them the whole way. The real advantage for us, of course, is it means we can leverage that capability. As Daniel said, we don't want to spend $10 million on a hydrothermal oxidation laboratory or a fermentation laboratory. You're able to leverage that sort of thing. In addition, it allows us, of course, as a startup to leverage our own funding very effectively. Some people would say BPA is the easiest money you can get, but it's close. Mostly, but I'm emphasising, because the processes are clear, the decision-making is clear, the decision times are fast, you're not running around wondering whether you're going to get the money, you're in or out, and we think it's a very efficient mechanism, which others need to copy. So the current work we're doing, working with these two teams particularly, and just a couple of the elements of that. Technical delivery, so this just shows you what happens in our technology. So this is sheep manure on the left, and working with AgResearch and Scion, we're doing testing on does it actually work before we put it into our expensive pilot plant and wreck it, and you can get a sense of the reaction that's going on. So over 30 minutes or so, the only thing that's left in that waste now is concentrated vinegar that can go on to make methane, a concentrated ammonia, which we can recover, water, which we want to reuse, and then the bottom is the ash. There's no organic material in there, and all the phosphorus is in that ash. So this is a very, very clean process. That's what we really like about it. So particularly Scion being critical to doing that, and that's allowed us to then do trials in our prototype with some safety. Also working, there's a poster out in the area there that I think you should look at, working with Scion AgResearch about the greater national good, and that's around, we've helped support the development of databases on where are all the agricultural waste streams in New Zealand suitable for anaerobic digestion / Ceto boost, the volumes, the offset opportunities in terms of greenhouse gases, the methane potential, the ammonia potential. These are very useful decision makings for where to put Ceto hubs, and also understand opportunities for other uses of technology in the waste X space for agriculture. And finally, our journey overall is a global one, so what we're really saying is our technology is really about helping the world defossilise. We can't live without carbon, is one of our big metrics. Natural gas is kind of important for a lot of things, not just for energy. So energy security is big, and our technology develops that by turning waste into resource. That means we get waste circularity, which means we eliminate the greenhouse gases from the waste, and we lower the greenhouse gas profile for fossil natural gas. That's the triple win that we think we get out of our technology working with the BPA, AgResearch and Scion. And finally, that's what we're about. We're building renewable futures with the deliberate intent of having no waste left behind. Thanks very much.